Hey folks, it's George Leoniak and welcome to New Geometry. Today I'm going to do a little bit of a follow-up video to my previous video on this topic of compounds. The previous video was on a compound of 5 dodecahedron plus 1 equaling 6 in a kind of unique compound of the dodecahedron. And today we are going to look at the icosahedron, and we're even going to put them together into a ultra compound of both the forms, creating a compound of 6 rhombic triacontathedron. And it sounds really complex, but it's going to get a lot simpler at the end because all this always leads back to a more simplified view. So I'm looking forward. I've got my slideshow set up. I've got a bunch of forms that I'll be sharing with you throughout. So let's hop into the sharing the screen and starting off with just a little background. If you're new to my channel, or if you've been here for a little while, you know that a lot of my work that I've been producing as of late has just been looking at the icosahedron and the dodecahedron as they're presented just in the traditional way that we see them. The last video was much more on the dodecahedron, but this is the icosahedron that you typically see in many posts or in different books. And, I'm just starting out here again, but I want to just reiterate this again, that this icosahedron really kind of locks us into a very unexpansive, interconnected sacred geometry. And I'm really hoping that these changes with the icosahedron that I'm going to present and I'll be demonstrating will open up a sacred geometer's aperture to allow for many more combinations of all the platonic solids and compounds of them and truncations and all those things all can happen. But the biggest thing that's missing is that this one, which is the correct drawing 2D projection of it, has the golden ratio. One golden ratio circle is all it takes in the seed of life, and it's not even that hard to draw. And once you do that, you're able to get a pentagon that is, if it were flat, will reorient to this angled version in the icosahedron. And I mean, this is huge because this creates a little bend here, and this is just a portion of an icosahedron that's over here, the 20-sided platonic solid. That you could see has a bend. Now, I think this can be very obvious to people who are into geometry. You can see right here that this is distorted pretty bad because this should be a parallel line with this bottom line here. As if you were to draw a line from here to here, it will follow this line because that's supposed to match the angle. But this is not a pentagon here at all, because it's an equilateral triangle, which means that this is flat there. This is a flat design that this triangle nests inside, and that's flat too. And, the more you study this, you'll see that there's no back edge to the pentagon because it just goes straight across, whereas this is supposed to have a point back here. So I'm really been hammering this for a little bit, but you could see here that this is not a perspective drawing or anything like that. I don't even have to draw the whole Metatron's cube. You can easily just draw the equilateral triangle and the hexagon and just connect some lines. But this is pretty big because this is pretty much what you see on t-shirts, caps, the internet posts. It's just going on and on and on. So there's my this overview of this material. Maybe, I don't know if it will be for the last time, but I'm kind of getting to my limit, but I know I have to keep sharing that because I want to show you what happens when you do correct the icosahedron. Now, this is from another view, and we're going to switch back to the hexagon again in a second. But the golden ratio, and this is from the pentagon perspective, is just essential. And what I've done with this golden ratio, which is normally what we just think of pentagonal geometry, is introduce it into the hexagonal perspective by just adding the same phi ratio circles that you see in this drawing. And I'm creating these clusters of forms. I'm going to have to do a whole nother video on this. But it's really just the kind of start of what's possible. Here's just a colorful version of that. Okay, so now let's just go back to the hexagonal view and the seed of life view, because really those circles, they 6 circles around the central one, they pretty much set you up to draw hexagons very well. And it's the most popular iconography that we typically see is either the flower or fruit of life or seed of life. So I'm really spending a lot of time introducing these, talking and discussing about introducing these phi ratio circles into the form. For one, to just basically create the one icosahedron that you'll see here over to the left. And there I've done the dotted lines in the back, and you can see how the parallel lines are matching up, and all this is checking out. It's all good. But today we're going to take that a little bit further because, you would really not be able to create a compound of 6 icosahedron or 5 icosahedron or 3 icosahedron. So I'm going to start out just a little more simple here, because this is basic design of the golden circle seed of life, because I only really have one. I only really need one, like I said in here. And you see the kind of orangish yellow icosahedron in the center. Well, just focus on the triangle. So we've got one triangle in the middle. We got a blue triangle here. Now that's going to connect to this blue hexagon over here. And I'm going to have another red one over here. I got a red triangle, and that connects to this red hexagon. I can do that just by taking this phi ratio circle and putting it and placing it around the outer circle here to create the form here. And this is 3 icosahedron. I'm going to add the other 3 in a moment, so we will have 6. But this is I find it to be a very interesting pattern that really looks very cool with this little ring of golden circles. But this will very easy to draw. I'll probably do this with my apprentices coming up in the next session, because it's that easy, and it allows the ability to draw these 3 icosahedron. Now, okay, well, why do that? Well, you see, it's actually connected to a larger picture, because once you start correcting the geometry in terms of phi ratio, including it in these to especially work with the phi ratio based forms, meaning dodecahedron and icosahedron, well, then all of a sudden the magic of the interconnectedness of the phi ratio starts to make itself known. And I was very surprised, and also kind of not totally surprised, but when you do these triangles, the red, the yellowish orange color, and the blue, that actually creates the vertices that you need between the triangles of those 3 icosahedron to create Coxeter's 9-pointed star, the icosahedral 59 stellation diagram, which I have a whole video on, which I'd recommend checking out. Is in that I rotate this star around and show you how all the platonic solids and other forms are generated from this 2-dimensional star that Coxeter did back in the 1940s or 50s or sometime in then, with the help of some other mathematicians and geometricians. So this star is really unique, and it just showed up in the symmetry of the geometry of doing these 3 icosahedron here. So yes, that video is called this star, this meaning this one here, is a key to understanding sacred geometry and something about Coxeter's stellation diagram. Very cool video. And now we're going to bump it up, because really, even within just adding these circles around the outside, it gives me the ability to draw the other 3 icosahedron, which are now not going to be from a hexagonal perspective. This is a new view that I believe, at least in drawing techniques with sacred geometry, compass and straight edge, right? Compass and straight edge, to be able to do your drawing, all I need is these circles, and I'm able to draw a new view. Now, of course, this looks like a pile of lines that have just been placed in front of you on your screen. And that's in all this kind of chaotic expression here. There is an underlying pattern that exists, and I'm going to show you what that is in a moment. So here's the blown up view of it, so you can get it without the circle pattern. And here this one in the middle is kind of like the keystone, the golden one here is kind of the keystone icosahedron in the pattern. Now that's the +1. The other 5 are going to make a compound that is traditionally known as the compound 5 icosahedron. As I mentioned in the dodecahedron video, they also left out the +1 dodecahedron. I don't know if they left it out, but whatever, it's not in that model. But when I'm drawing sacred geometry, and I'll show you in a couple slides of how this was constructed, the 6 dodecahedron is the anchor point, or the 6 icosahedron is the anchor point for the rest of these to build off of and relate to. Okay, so we know we've got these. Now the other ones, let's just make out one of the pentagon faces. Let's just focus on the black. Radiate out 1, 2, 3, 4, 5. There's a pentagon with 1 bar going across, 1 bar going down the side. And then we've got a triangular face here, a triangular face here. And the triangular face is very narrow on the upper portions over here, but it's there. So like I said, we're gonna show you that in more detail. Thankfully that there's a software out there called ZonePad. So I do build these models. And the first model I drew of this version of the 6 icosahedron, I tried to draw it just from looking at this and using the techniques of drawing sacred geometry. And I actually made a pretty critical error in there and thought I had solved it, and realized midweek that I made some ugly looking icosahedron that I thought were good, but I just very fine distorted. But anyway, so this I'm able to rotate around. Some of my videos, I show that, so I'm not going to do that today. But once again, these are all the color-coded ones, so you can kind of take a look. Now, I've done them from 3 different views, which I like to call pentagon view, square view, because there would be squares easily drawn within this, and the hexagon view over here, like the seed of life view. I know it looks like a lot, and it was a lot to build many of these, but I'm going through all this complexity really because it was going to get simpler, but I don't realize at the time. And the drawing I said where I made the errors, that was the toughest drawing I ever did. And I was like, this is getting a little too complex for me. But then when I realized I made the mistake, I came back and simplified it to just these circles, when before there was a gazillion circles all over the place and it was just out of hand. So I knew I was not doing something correct there. And that's how sacred geometry informs you. But whether you plow ahead or not is kind of your personality traits. But thankfully, I was corrected along my way. So here we go. We've got, this is a little bit of the description of how this is working. And I've got a little model on my left here. I'm going to pop out of the video just so I could show that closer, because I often say to my viewers, I'll show you all the models at the end and completely forget to. So I'm going to do that in just a moment, because it doesn't take much to jump back and forth. But this is the key feature. This Icosahedron is there was one in the center, and this was the foundation. Now this is a picture like either a truncated icosahedron. So if I take these off, these little caps, then I'll have an icosahedron. Similarly, if I got a dodecahedron that's meeting the same locations, and I truncate that, well, I'll also get the icosahedron. So this form is kind of like a cube octahedron. If you're familiar with this little very popularized form, then it's kind of the in-between of octahedron, which would be built off the square faces, and off the triangular faces you'd build the cube off of, and the two together can be a compound. And this would be, if I put the dodecahedron in here, that would also be the compound. But I did something interesting with it, is that instead of just following the traditional placement of these bars of the icosahedron, you see how that goes right across between those little triangular faces? Well, I said I'm going to do the same one. I'm just going to extend it this way to make a T, pretty much, not a T, just an X, right? Just make an X. And I'm going to do it over here. I'm going to do it over here. I'm just going to see what happens. And they crisscross in the middle, and they create this little triangle in the middle. And this is all important. But what I'm basically getting to is that when I do that, I end up with the one blue icosahedron and 5 more. And that's the 5 in 1. Now, what Wolfram Math and like not many sites talk about these forms, but for some reason they don't have the blue icosahedron, but it's like the stabilizing form in doing the drawings, and it's actually part of the icosahedron build out, because there's an underlying form below this, which is this. And once you know that this is underneath this, this is not very complex to get into building. this is a totally different form. Now, this is a compound of 6, and I haven't gotten there, and I'm not sure I will. I'm not sure how that one's going to present itself, but it's a possibility it could pop up. But so this, even though I'm saying sometimes that this is a compound of 6 and what I'm sharing, it's actually this with the icosahedron that would be poking out of these 5-pointed stars that you see here in these little divots. So, okay, that's the explanation of that. Let me just stop the share so I could show you just a portion of the form that is going to describe this a little bit better. So here is the triangular face of one icosahedron. That would be the foundation one. And you can see that the bar is going across, and this actually contains a portion of the dodecahedron that would create this little ring of yellow. That was from the previous video. But now here's where on the dodecahedron, now that's this blue triangular face in the middle, and that's going to extend back over here. And that was the crease spot, right, where it's going to meet over the top at that vertice right there. So here's the one that traditionally works out. And now this is the other one that's extending through. And you see, I'm going to have one coming from this way, and they're going to create this one coming this way, and one coming from down here and up, and then they poke out the top around here. So that was the that's how I kind of went about that, and this all led to some more discoveries, but we'll get to that in just a moment. Let's get back to the sharing the screen and keep with that flow to where I was headed. Okay, well, I do want to show you that these are what the other icosahedron. Now let's get out of all the complexity of all them overlap, because there's actually only 2 views here. They're just oriented different. So these are the 3 hexagon views of them. And now these are the other 3. And this is kind of the primary one down here, because what this is, and it was very cool to discover that this view is of this icosahedron as if it were on its base. Like if I just put it in my hand like this, resting solid, there it is. It's just, that's the view. It's oriented this way, right there with the pentagon there facing down. So that's the view. It's sitting right on its face, which is a very cool view. And it's really kind of amazing to me, as I'll describe probably in the next few slides when we look at that a little closer, that I can actually draw that in the golden circle seed of life. And these are the same thing. They're just oriented, tilted, at 30 degrees there. I just wanted to show you that the dodecahedra 5+1 model that was in the previous video is doing the same thing. And I guess I didn't even realize it at the time until I did the icosahedron video, or this video I'm doing now, that earlier this week. I was like, wow, that means that this dodecahedron is actually, because it's a dual of the icosahedron, if this is flat on the top and bottom, that means that the vertice of that dodecahedron is right in the center point of this, which means that, wow, I just reoriented the dodecahedron to its vertical axis, or I don't know, vertical, but I mean, it's a side view, let's just call it. And that will put it right on the top and bottom. So that's this view here. And of course, these are also coming in from that perspective on the bottom 3, and the top 3 are the kind of hexagon version of that. Let's just take a quicker look at these, right? So I didn't need to put in as many circles. It's pretty easy drawing to do. In fact, everything in this that you need to draw this is all the lines are already presented here. So anybody could do this if they just added the golden circle and draw out the rest. You can make this version of the icosahedron. So let's see. Yes, they're flat on the base, and this is only needed these little golden circles here to kind of locate these other locations along here. But as I was just saying, I mean, it's totally amazing to me that I can take the golden circle seed of life, which is, I could draw pentagons in here, and I can do that as well. And I can even orient it into the square view, but this is a really radical transformation of the perspective. And I want to show you how to do that with the dodecahedron too, which I can also do from the golden circles diagram. So the golden circles are just like where it's at in sacred geometry for me, because it's doing things that I'm not seeing anywhere else. Like you can make this on a computer and rotate it and look at this, but how do you apply this to the techniques of the geometer with the straight edge and compass to actually go in there and find the ability to do this? Because I do this on the iPad, but then bring it back out and say, hey, this is now pattern, part of our pattern language. It's not just all sophisticated technology, computers doing the work for us. So here is my the dodecahedron version on the vertex. Just a few additional circles that need to be added in here, but not a lot. You know, go in there, and it's all phi ratio based circles that are going to be establishing these vertices. Now, this is I didn't know this at the time, so I'm thankful that I continued on with the icosahedron, because look how simple this was. I don't have the dodecahedron that I drew within this last one, but if you checked out my previous video, and this is probably the reason why that video may not have many likes, is because if you see something like this, which is just mind-blowingly amazing how these phi ratio circles all will produce a compound of 6 dodecahedron, and it all actually is a very consistent, coherent pattern. But when you look at this, you say, whoa, yikes. That's what I said when I looked at that. And really, I could draw the other 6 in here with just following this simple template here. So the icosahedron compound kind of simplified dodecahedron ether perspective, and let's just say brought a little bit more to life. So here is, let's now just, because we're going to do this compound of the rhombic triacontahedron, which I talk a lot about in my videos. I feel like it's a very big step in our understanding of sacred geometry, is to move a little bit past our understanding of just the basic platonic solids and get a little bit more into the compound forms, the dodecahedron and icosahedron, cube and octahedron, you know, so expanding our horizons, more words, more rhombic-y type of things, putting in front of titles with longer things, but basically it just means 30 faces that are diamond shaped. So we should just call this form the 30-face diamond shape. So it's got 30 faces here, the diamond-shaped 30-faced form. So here we go. We got this new view. So I'm going to do this all from a kind of new perspective here for you. And this is now looking at it from the side view. So our dodecahedron, and this means that the rhombic triacontahedron here is, you know, going to be oriented on the cube, which actually means that, because that's a cube now in this, because there's 5 cubes in that dodecahedron that's on this vertice, which means that this perspective that we're looking at has oriented the star tetrahedron that is in this. It was just one of them. There's actually 10 tetrahedron in this, large ones like this, which means that when we're looking at this now, we actually have a side view of our beloved star tetrahedron, that it can actually look at it from the side and visualize the picture of what it looks like on its axis of rotation here with the cube tetrahedron points, vertices straight up and down. That's what this perspective is. So there's the dodeca, there's the icosa that are compounding together, and those faces cross right at the midpoints. And then now we can connect those dots and create those diamond faces. And we come on down here, and now I'm going to remove those icosa and dodeca, and then we get, you know, the rhombic triacontahedron, the 30 diamond-faced form. So that's what we got going on there, and it's drawn in the golden circle's seed of life. Now, I didn't think I was going to do it, but I did. I said, well, now that I've done that, I guess I have to see what happens with all 6 of them. And yes, I did decide to put them together. And I did cop out on trying to do the drawing, but that's okay, because you know, I'm going to show you the modified version of where this all leads to, like the simple form at the end, because it does get complex trying to find all these lines. But you know, we're going to take this 6 icosahedron, and we're going to drop it on top of our 6 dodecahedron, and we're going to get something that looks like that. Now remember, I just illustrated to you that when we do these compounds, we've just now created 6 rhombic triacontahedron, And probably traditionally by like Wolfram math standards, but I did check their whole site. I was not able to find anybody who's done a compound of 5 triacontahedra. And but this is where it kind of all leads, is like what's going to happen when we make that compound. So I went into the Zone software and just decided to figure out how to draw it there. So to do all the underlying stuff below this and removed all that. And you might be able to make out some triacontahedrons in here, but there's a lot of crisscross of lines, but it actually does kind of work. And you might be saying, well, why go through all that? Well, I just have to kind of see what happens, I guess. Because I still have a feeling that there must be something at the end of this rabbit hole that I'm going into, because I just don't picture people getting really too psyched about trying to draw something like this. I mean, it would be totally awesome, but believe me, it takes a lot of effort and time to figure it out. So yes, there is something simpler, and this is what it looks like. So this is what I thought the culminating form was till about 9 p.m. last night. I thought it was going to be this. So here would be the culminating form. I'm going to show you how it's drawn in the circles in the next slide, or how it can be drawn in the circles. And what it really does is it just starts to connect the dots between things. And, you know, here's the central icosahedron. The dotted lines in there are actually the vertices, as if I were to do the pentagon or the pentagram within this. Well, magically, that will create that pentagon right here, which will give you the vertices, 1, 2, 3, 4, 5, plus these, of the compound of 6. So you can kind of like bypass all the lines and just kind of go to this and realize what you actually drawn here is actually a compound of both the 5 and the 6. So we've got the 6 icosahedron, the 6 dodecahedron, and then the 6 triacontahedron, which is the combination of the two. So these are golden rectangle faces, 30 of them. We got the 20 triangles connected to the icosahedron, and then we got the 12 pentagon faces. And the underlying vertices are all underneath here. So I thought I was done. I thought the video was like, that was it. Okay, and here it is the drawing. I can show the same little circles that go around the ring around there, ring of golden circles going around, and I've got my dotted lines. I can show you where those pentagon stars would be to the pentagram stars, creating the pentagon inside, which are the vertices of the 6 dodecahedron. Got my shape, and then I was like, you know, this looks a little bit like a zone ball. This is a zone ball right here. There's a pentagon in the middle. There's a golden rectangle face, and there's the triangle. It has the same number of faces that are adding up on this. The orientation is a little bit different on the golden rectangle. And then I remembered that, oh, the Rhombic Icosa dodecahedron. See, I haven't done a video on it, but there's different versions of that. And I said, I bet you this is probably one of them, because it looks like I can make the rhombic triacontahedron out of there. So I went over to the site, and yes, there are 3 different versions of this Rhombic Icosa dodecahedron. And I don't know if Kepler discovered all 3, but Kepler definitely discovered at least one, because they mentioned Kepler 1617 book, or around 1618, is a Harmonics Mundi book. He mentions on that site, they talk about this version of the Rhombic Icosa dodecahedron. And this one was different than the others because this form, now this is the same form. Now I want you to just get this, see how interesting this is, because these vertices here of these triangles that are showing up. Now I've taken out that 6 icosahedron. Now this is 5. This is 5 icosahedron that are giving you the vertices of this. Underneath that, I don't know if they know that that's what's creating this vertices. Like, I don't know if Kepler knew that, because This is pretty complicated, as you can see in the drawings, to figure out that there's another bunch of icosahedron in there. Maybe they did, but it doesn't take too much just to connect the dots and see it. So I'm imagining they know. But the neat thing about this is that it's actually the internal kind of core of this rhombic triacontahedron and the Icosahedron. I'm going to show you slides of that in just a moment. But this is now their compound. So remember, we've got some compounds here. We've got a cube and a octahedron. And those two, when they compound together, they create a form. They create the rhombic dodecahedron. Now that looks like this. Okay, the Pythagorean people, Chelontics folks, love this form because it's a square and an octahedron, and it's just one of them. Now everything that I share here can either have 5 or 6 of these versions, and in a more complex 5-fold geometric symmetry. But this is now one cube and the octahedron. So that's the compound of those two. Now you also remember the compound of the icosahedron and the dodecahedron. These two, when they compound together, what you get is this one, the rhombic triacontahedron. Now this form, when it compounds with this, you get a new form. And just like this compound of the cube octahedron has an internal hull of this cube octahedron, that's the internal hull or core. So that's got the core. This is the core of the icosahedron and dodecahedron. So the core of the fusion of the icosahedron and the rhombic triacontahedron, these two, is this form, this rhombi dodecahedron version. You see, it's just like a natural progression. I know I'm a little person on the side of your screen right now, and maybe I'll just do that at the end one more time, because it's like a progression in sacred geometry that this form is getting very little airtime, but it's really a critical form because it's actually a compound of a new form that's been created that has really nothing about it. I'm going to get to that. So here is the rhombic triacontahedron, icosahedron, same image. It's all the way down the left because they're just showing that these two come together, they compound. Now a compound is just the crossing of the lines, and they cross and then they continue on, and then you can connect the dots basically. So that's what I did. I just decided to, compound them and just draw and connect dots and connect the lines until I came up with this. And it's got these kite faces to it that has a dodecahedron and an icosahedron built into it. And remember, I just want to make sure that everybody's still on board. Like, the only reason I got to this is because of this inner core, and that inner core was connected to those 5 icosahedron, right? This inner core is what got me there, because this is the 5 icosahedron compound that are giving this to us, plus 1 if we put the core, the kind of orienting one down on here. But that point doesn't actually give you the vertice up here. It's a little bit below, and that's interesting. So here we go. We connect these dots, and now this comes up, and that was this morning. So I was just like, okay, well, what do I do with this now? Because it's kind of a whole new exploration going on here. Do I include this in or not? But I'm like, okay, can I even draw this in the golden circle seed of life? Yes, I can. And I do have to add an additional circle because I can do the icosahedron points easily, but I have to get this one, and that's very, very doable. And then I need another phi ratio circle in relationship to that one to get the hexagon, to get the triacontahedron in there. And I know this is probably sounding like a very advanced sacred geometry lesson at this point. But I hope you're still with me, and it is stretching stretching your ability to visualize these forms and see how they all interrelate, because I think a real detriment to how sacred geometry is presented on the Wikipedia sites and many of the other sites is if it's not like, most of the basic forms are very, very good, but most of them just look at a lot of these forms as like, well, they're kind of like hollow forms. Now this one is 5 octahedron that create the icosahedron, so that's the platonic solid, you've got 5 of these octahedron creating this one, and that's pretty well known. But now we're getting into these compounds of 5 icosahedron, and creating a whole nother internal structure. So it's kind of like a whole bump up in our ability to see the underlying connections of what appears to be a vertice of a form that is totally, definitely not hollow inside. There's just so much complex geometry in them. Check out the golden matrix of infinity video. So, okay, so we drew it, that's good. And then I was like, okay, well, I can draw it, but I want to build it because that's an important step. So I built this earlier this morning. I have it next to me here. I'll show you definitely at the end of the slideshow. And I also wanted to do the mathematics on it, which, you know, the software drawing program that I do, it doesn't just spit out these numbers. So I have to actually do some real math. And the way I am able to do this is with one of Kepler's treasures, the measure of gold. The Pythagorean theorem, of course, allows me to calculate all of these angles, but I have to find a starting point. And thankfully, Zone tools help me out because I know that I can figure out this red line is 1, and then I can figure out the rest of the root 3 and 2. So there's a 60 and 30 degree angle on this. So there's some very cool sacred geometry connection to the mathematics that are in these kites. So these are the kites. This is the Icosahedron blue. This is the Rhombic triaconthedron red. And where they're crossing, they're creating this very cool kite. There's a very cool number that came up, and maybe this is just for a particular set of viewers. 3.13912 is this edge length. It was very, very close to 3.141 or 3.144 for our value of pi that is out there. I was very surprised to see that. And this number, I think, has some significance that I'd like to know more about. So now that rhombi Icosahedron has a square-faced version of it that has this dual form that is called the deltoidal hexacontahedron, which I was like, oh, well, these are called deltoids because they're kite. So I was like, well, maybe this is the dual form of the of this form with the golden rectangle faces. And I do believe that you know, it could be, I'd have to double check it with some other way to see if it matches up internally and everything like that. But I did take the regular deltoidal hexacontahedron and put it over top of the drawing, and just to illustrate that it was not a match, which means that this form, deltoidal version, associates with the other rhombi Icosahedron, Icosahedron. And this one, I'm assuming, relates to our new form, which is the internal core of the compound of the rhombic tricontahedron and the compound, and the Icosahedron. Now those two, remember, those are let's just show you one more time. So I'm not just using words. I want you to see the visuals. These two forms come together, they create the inner hull, the inner core, which is this inner core. So it's kind of like a new cube octahedron-y type thing, you know, vector equilibrium. Of course, not vector equilibrium at all, because it's not equal edge lengths to the inner radius. So this is off of Wikipedia. That's the one deltoid from this form that was on the site. And you can see that it's not going to match up with our mathematics that I did for the other form. And okay, that is our big presentation of the compound of the 5 plus 1 icosahedron. Took you on quite a geometric journey there. This is kind of the circles that you need to be able to draw the 2 in a compound form, Icosahedra plus the triacontahedra, and along with that new form that's in there too. And let's stop the share. And before I do, though, I guess I do want to point out, a couple more things about this. Is like, there's a lot of sacred geometry that is sacred geometry that is on, Wikipedia sites and Wolfram math sites. And there really isn't a sacred geometric language. Our pattern language as geometers hasn't really had the ability to interact with a lot of these forms. So even if what I'm presenting here is something you might never picture yourself drawing, just realize that it can be drawn now with a compass and straight edge. This form is all I needed, these circles and a few other lines in here to help do it. And it's actually making this accessible to the young geometers that are out there before they even get a chance to, or before they even start to get computer technologically oriented, to have the computer do all your symmetry and drawing for you like this, and programming with the mathematics. Now, I'm not really well versed in that material at all, but I am well versed in looking at these patterns in sacred geometry and realize that this is quite a significant upgrade to the ability for young geometers or budding geometers to access forms that were pretty much off the radar to the general enthusiast or hobbyist or someone who's even really passionate about this subject. And it really just takes adding golden ratio circles to this pattern, at least from this perspective, and all the other ones, if you're going to do icosahedron and dodecahedron. If that's not happening, it doesn't have to be the way I call it, but if it's not happening, then what we have is, the flower of life and the seed of life as they are, which I love the patterns because they're right here. So there are totally foundational root structures to drawing from this perspective. But all they'll do is create, things that look like this, which are the icosahedron that is not going anywhere. It's just going to be stuck like this. And the same thing with the dodecahedron. And then all this other stuff that I just showed you is kind of inaccessible until that box is broken out of, because this is meant to be just drawing cubes and octahedral symmetry and tetrahedron. So that's really, my takeaway thing for probably all these videos that I've been sharing is working with the golden ratio circles. There's many different ways to draw this, many different solutions to the same situation that can be drawn many different ways to get the same thing in the end. So the creativity is boundless for what can happen with this. Okay, so that this is the form of the deltoid kite structure, right? So it's got the kite structure with the diamond shape, red diamond shape on there, and that's your rhombic triacontahedron. And this is now part of your Icosahedron. Now they don't cross right in the midpoint here. They're crossing at this point, but these are all flat kite faces as I'm holding this here. And we've got a few different views to look at here. We've got our pentagon structure. Now this would be quite a cool wire structure and not very difficult probably to make. Here's our pentagon view, and we have two of what I call the happy stars, these little inflated stars creating this triangular face and the diamond structure there. And then we can go over to our square view, right? So you can see the way that these two are integrating here. And we got our hexagon view, which is primarily the view that I've been drawing to. Now I've got a lot of homework to do, because now I can go back to the other views that I haven't drawn at all and do the same. This is how I was showing you mostly the drawings were like this. Let's get it off the non-tape side. So, most of the drawings were like this, but like I said, I can go back now to the other two views and figure out how to draw this from then. just to, rework my orientation, because, when you do that, you start to discover something you didn't see, and that will lead you down another path, and then you jump from that view back to another view. So it's really like, you're in a dance with sacred geometry. And in order for me to create this, like I said, I had to use Kepler's treasures, the measure of gold and the gem of the phi ratio and the Pythagorean theorem, but I actually didn't have to do any math to create this at all. Pretty amazing, right? Because all I needed to do was just do the geometry and measure edge lengths and know what edge and make a flat kite and let the form create itself by putting those kites together. So that was all that really needed to happen. It's very user-friendly for people who are of a non-mathematical orientation, but it will teach you quite a lot about math. So it's one of my new favorites, and I really appreciate you coming out to check out my video, new geometry video today. And I have a few other offerings. I got apprenticeships that I teach people how to draw and build these forms, golden circle seed of life. That's quite a bit on that. And I have a Patreon site where I have lessons that are coming out and a monthly meeting and things like that as well. And New Geometers on Facebook group, check that group out. I mean, it's really exploding with a lot of enthusiasm, other great geometers sharing so much great work there. So I'm just very happy with how that's manifesting. And I think that's probably about it. So I really thank you for coming out again, and much love and peace, and enjoy the rest of your day. Until next time, see you then.